moly. It's time for moles. This is the big one. If you've talked to anybody who took chemistry last year or the year before, they may have memories of moles. They may not remember how to do it, but they probably remember that we did it a lot, like a lot. We will do moles so much. So holy moly, let's get started. I'm going to be color coding a bunch today. So if you have at your disposal access to yellow and green and blue colors, then, you might want to get started on grabbing those. Maybe pause this and grab those. If you don't have those, it's okay. You don't need them. They're just an extra way for me to talk about it, to help you picture some things. But if you don't have access to those colors, really not a big deal. You can absolutely still learn this without being able to color code yourself. Or like for my colorblind friends, it's fine. You don't need the colors. It's just an extra tool I can offer to help visualize things. Ultimately, don't actually need it. Don't worry about it. Okay. So, let's talk about them all. Sometimes we use specific words to represent a certain number of things, such as the word pair or the word dozen. How many items are in a pair? That means two things, right? A pair has two things. So if Sam has 28 pairs of socks, how many total pairs of socks does Sam have? 28 pairs times 2 in each pair is 56. Yeah. How many items are in a dozen? A dozen is 12. Oops, there you go, 12 of something. If Mr. Dado ate 6 donuts, how many dozen donuts did he eat? Well, 1 dozen is 12. He ate 6 donuts, so that is a half dozen donuts, half dozen. We need a bigger unit to count particles because they are very, very small, and there are a whole lot of them. And the unit we use is called a mole. We need a mole because it counts for very large quantities. 1 mole of anything has 602 items. That's 602 sectillion for what it's worth. We call this number Avogadro's number, and it's usually written in scientific notation because that's way less tedious than writing all of those zeros. 6.02 times 10 to the 23rd. 1 dozen is 12 things. 1 pair is 2 things. 1 mole is 6.02 times 10 to the 23rd, or 602 sectillion items. This is a really hard number to wrap your head around because the human brain is not really made for quantities this large. But one way to think about it, if you think about how many grains of sand, like each grain is one like tiny little piece, right? How many grains of sand there are on one beach. And then you think about how many total beaches there are in the world, like ocean beaches, lake beaches, river beaches, like every single beach, underground lake beaches, okay? The number of individual grains of sand on the planet Earth is estimated to be roughly 1 mole of grains of sand. So that's how big of a number we're talking about here. You think about like how many millions and billions of grains of sand are on a single beach. It takes every single beach on the planet to get to 1 mole of grains of sand. We're talking about a very big number, but that also tells you how small atoms are. Because if you were thinking about how small is a grain of sand, and it's still a planet's worth of grains of sand to get to 1 mole of pieces of sand, well, 1 mole of carbon, I can hold in my hand. If I have a mole of carbon atoms, it actually fits in my hand. So that tells you how much smaller than even a grain of sand atoms are, that I can fit a mole of carbon in my hand versus a mole of grains of sand. A grain of sand is so much bigger than an atom of carbon that it takes every grain of sand on the planet to get to a mole of grains of sand. Another way to think about it, if you had a mole of kittens, like newborn kittens that are like this big, if you had a mole of those, meaning 602 sectillion little tiny newborn kittens. The pile of kittens would be roughly the size of the moon. Like it would actually be a little bigger than the moon to have a pile of newborn kittens that was 1 mole, 602 sectillion individual kittens. Okay, I need you to understand, when we talk about a mole, we're talking about a very, very large number. And if you're struggling to think about how big that number is, I will put 2 more links in the video description of different places. One's a video, one's a article you can read that can help you think about how big is a mole. With that being said, we're going to talk about doing some math, because this is chemistry and math is what we do here. So 1 mole of anything is 602 sectillion. That's 6.02 times 10 to the 23rd items. 1 mole of anything has 6.02 times 10 to the 23rd items, just like a dozen of anything is 12 items. We need to know the 2 basically types of items that we will be talking about in chemistry. We talk about atoms, which are the smallest particle of an element. A particle means like a really small piece. For example, any of these, if you have just one of any of these elements, you have an atom. And then we also can use the word particle, which is a more generic term. A particle is any extremely small fragment or portion of matter. So like you could talk about a grain of sand as a particle. In chemistry, we're usually going to use particle to mean either an atom or a molecule. So an atom is like just one of one element. A molecule would be several atoms of possibly multiple elements altogether. Okay, so let's think about what we know. There's some examples here. How many Dalmatian puppies are in 1 mole of Dalmatian puppies? Now, at this point in time, if you're thinking about the definition of a mole, you can probably do this in your head, but I don't want you to do it in your head, because pretty soon it will not be something you can easily do in your head. So we're going to show our work with conversion fractions. If you don't remember what I'm talking about when I say conversion factors or conversion fractions, you need to go back to a previous unit to a previous video in this unit, find the fractions video. At the time of this recording, it was video part 2 for unit 3, but that may not continue to be true in the future, but it will be labeled fractions. Find the fractions video, watch roughly the back half, which is about conversion fractions. If you remember conversion fractions, cool, let's move forward. We're gonna start with this thing that they're giving us, 1 mole of Dalmatian puppies. Find the number they give you, and write that down as your given. We are going to be multiplying by a conversion factor, which will be a fraction. If multiplying fractions is more comfortable for you to write this one over 1, you can do that. You don't need to write it over 1. Some people find that easier to look at and know what they're going to be later putting in their calculator, so I just thought I'd bring that up. If we think about converting, we know that we're going to want to simplify this unit, moles of Dalmatian puppies, so that we can kind of get rid of it and not have to worry about that unit anymore, because that's not the unit we want. We don't want moles of puppies for our answer. They're just asking us about individual puppies for our answer. So I'm just going to put D puppies. But we can see if I have the same thing on top and bottom, that simplifies out. And then I can solve for, instead of moles of Dalmatian puppies, I can solve for individual Dalmatian puppies. And I know from the definition on this same page that 1 mole of something is 6.02 times 10 to the 23rd of that thing. So if I have 1 mole, that's going to be 6.02 times 10 to the 23rd Dalmatian puppies. And if I'm really paying attention, I'll see that I'm just multiplying and dividing by 1 all over the place here. So it doesn't actually change my answer. And I have 6.02 times 10 to the 23rd Dalmatian puppies. Cruella de Vil would love that. Example 2. How many atoms are in 2.5 moles of sodium? Atoms. Excuse me. Again, look at this thing they gave you. That is your given that you're going to start with at the beginning. You can write that over 1 if it makes you more comfortable to multiply fractions. If the first thing is written as a fraction, you don't actually need that over 1. If you don't want it, that's fine. It's not going to change anything. Some people are just more comfortable writing that over 1. So I thought I'd throw it out there. Again, if you think about converting, we are going to want to simplify out this moles of Na. So that's going to end up going on the bottom here. So I can go, oh yeah, that simplifies top and bottom. Same thing on top as on bottom, that simplifies out. And then if you look for your unknown, they're asking how many atoms. It's still sodium, so I'm going to label it Na again. And again, we're going to use the same conversion factor that 1 mole will have 6.02 times 10 to the 23rd of the thing in there. This time, you may want to actually do this not quite by hand. So you could put this in a calculator or whatever, but you end up with rounding to the hundredths place, because we always round to the hundredths place, 1.51 times 10 to the 24th. And then again, you notice, hopefully, that we've simplified out the moles of sodium, only atoms of sodium are left, and that's going to be our label for our answer, which is convenient because the question was asking us to find atoms. And judging by my math, it sure looks like I did. Final example, I'd actually like you to pause the video and try example 3 by yourself. And after you have paused the video and tried it by yourself, I'll walk you through it. So you take that 6.02 times 10 to the 23rd kittens that they're giving you. That's over 1. I know I need to simplify out kittens, so I'm going to put that on bottom so that I have the same thing on top and bottom so that they simplify. And then it's asking me to find moles of kittens. So that's my new unit that's going to go on top. I know that 1 mole has 6.02 times 10 to the 23rd things in it. You'll notice that this time our conversion fraction is written upside down compared to the previous time. That's fine. It's okay. Conversions are allowed to do that. And 6.02 times 10 to the 23rd times 1 divided by 6.02 times 10 to the 23rd is just going to come out to 1 mole of kittens.